Besides the one person I use. Okay, we're good. Very clear. Not so clear. Let's do the work. Alright, so for number 1, there's nothing going on in front or behind it, it's just y. So I can get right into the process of dropping the bars and solving. The first time I solve, I keep it all the same, but with no bars. So it would just be y is greater than or equal to 4.5. The second time I solve it, I have no bars. I flip the symbol and I change the sign. So the second time, I'm going to write y. I'm switching the alligator mouth to open the other way, and I'm changing 4.5 to negative 4.5. Those are your two scenarios. The number line for that I'm going to do real basic. I'm going to do 0, 5, 5, lazy number line here. This reads, y is every number greater than 4.5 or equal to, so I'm going to do a closed dot, and my arrow goes to every number greater, over there to right infinity. And this reads, y is all the numbers less than negative 4.5, so I close dot, my arrow goes left. There's my number line. Any questions on the number line? All right, now the interval notation. So for my interval notation, the number line is really helpful. This arrow means negative infinity. And then I look and it stops at 4.5. And it stops with a closed dot, so I put a bracket there. It includes 4.5. And then I have a whole pause, like none of this works, break. Starts up again. Starts with a closed dot, so I do a bracket. 4.5, where does it end? Arrow means infinity. Goes all the way to infinity. There's your interval notation. Questions on that bit? This marker's already a bummer. Number 2. Okay, there isn't a number here in front. There isn't a number behind it. It's already isolated. I'm going to get right to work. I'm going to get rid of the bars and try to figure out what's happening inside there. So keep the same with no bars. So I'm going to do 9 minus 4n is less than 5. Solve that guy. Now I'm going to do no bars. 9 minus 4n. I'm going to flip the symbol. I'm going to make the 5 negative. I solve that one. So I guess I have to minus my 9 over. And then I have negative 4 and also negative 4. Divide by negative 4, divide. Something's happening here. I'm getting a little reminder. Something I knew before. When I divide both sides by a negative, do I have to do anything with this inequality symbol? Special rule here. You gotta flip it. You guys remember that? Yeah. I remember it from first period today, but I don't know if you remember it. I don't know how long it's been since you've talked about it. In solving an inequality, maybe I told you yesterday, when you multiply or divide by a negative, you flip the symbol. So many flipping going on. Flip this. Technically, you're taking the negative side, so the other side of this thing, you're changing everything. Like everything has changed. We had a negative number, and now we have a positive number. Like that's a big deal. Flip your symbol. Everything's different. So this one ends up being n is greater than positive 1. Oh, flip my symbol again, divided by a negative. N is less than 7 over 2. The rule is if you have to graph something, you're allowed to write it in decimal form. So since we're putting this on a number line, if you want to turn this to 3.5, you can. Let's do it. Let's do that number line. 0, 1, 2, 3, 4, 5. Okay, this is starting at 1, and this number is higher than 1. Big open circle this time because it's not equal to. Going higher. N is numbers less than 3.5. Big open circle at 3.5. Less than, and it meets in the middle. This one went up, and this one went down, and they met in the middle. So I can plug anything in between 1 and 3.5 to this, and it would be true to the original equation. There's something I wanted to say about that. Okay, really clever, man. I can't remember. Oh, go back to those notes over there. So this started greater, and you can see that the arrows went opposite, so it's far away, greater. And then number 2 started less than, and the graph of number 2 is going together. Some pattern recognition there. It's supposed to comprehend it, but second best is pattern recognition. Now the interval notation for this one is really annoying. I kind of want to protest and write all the mathematicians of the world and say, why can't we use different symbols? You know? So this is an open circle, so when I do my notation, I use a parenthesis. It starts at 1, and it goes through 7 over 2, and it ends there. Both parentheses this time instead of brackets. And I find that highly annoying because it looks just like an ordered pair, right? This looks like an x and y point, and instead it's actually a range of values. So when you read this, you're supposed to think, oh, n could be anything between 1 and 3.5 instead of, oh, I'm going to go plot a point on a coordinate plane. But it looks exactly the same. So pet peeve of mine. Like, can we just get some different symbols? More symbols. That's what we need in the world, right? More symbols. No repetitions. Parentheses have so many responsibilities in life. I wonder if they get tired of it all. They're in sentences, equations, notations, emojis. Yeah. If this had been a closed circle, it would be bracket 1, comma 7 over 2 bracket. Do you get that? You get the brackets? Yeah. So if it's an open circle, you have to use parentheses. Open circle means parentheses, which is unrecognizable. Parentheses in your whole life has always been ordered terms. Now we're telling you it's intervals. What else are parentheses used for? Anything? Anything? No. Who else wants to ask a question? Full review of yesterday's lesson. This homework takes like half the class. Let's take a look at the answers then from 1.4. Page 59. Page 59. ¿Cómo se dice 59? 59? ¿Sí o no? Is it 50? 50? Yeah, Spanish 2. You gotta know that. Spanish 1, Spanish 2. How do you say 50? It's not 50. 50 is with an S on the end. Who knows? 59. 59. Yeah. Página. La página? Isn't it el página? Even though it's feminine? La página? La página? 59. I'm expecting people to be adding to their number lines, to be erasing, correcting, to be asking questions. There's two things. Did I do number 3? No. You guys. We can't move on without number 3. Jeez. Speak up. I'm just kidding. Sorry, guys. I suck. Number 3 is actually like maybe the most important one to do. I'm really sorry. Oh, how annoying. Okay, let's do number 3. I just remembered. It's been a long Wednesday. I don't know why. Okay, here it is. I'll do it quick. Anybody want this done quick? 6b minus 8 less than or equal to 12. All right, this thing is special, and that's why I just remembered it. I didn't talk about anything really special yesterday, but this one is special. There's something very weird going on here. First off, there's a number in front, so before I can start my 2 problems, before I can drop the bars, I have to divide by -4. And that has to happen before the bar drop. Or it'll mess up that second answer. So now I'm at 6b minus 4 is greater than -3. Flipped my symbol, divided by a negative. And now this is what's special. This is saying that my absolute value, as it is written right now, is greater than -3. Yes? Oh, gosh. Let's put an 8 in there. That 8 did not change. Move an 8 here and 8 here. That did not change. This says that absolute value, which means distance, right? It says that the distance is greater than -3. So I have to think about, even if I put, let's say I put a 1 in here, I have 6 minus 8, I get -2. What's the absolute value of -2? +2. +2 is greater than -3. In fact, it doesn't matter what I put in here. The bars are going to make anything in here positive, right? So this will always be a positive number. And positive numbers are always greater than negative numbers. So what's special here is I can plug anything in for b, and it will always be true. This is true always for infinity, true for all real numbers. There's nothing I can plug in here that would make this false. Everything's positive is greater than negative. So this answer is true for all real numbers. And I hope you checked your book yesterday one of your answers said infinite solutions. That's the same thing. I can put any number from infinity to negative infinity in here, and it'll always come out right. It's always true. Okay? And that is because my bars are still there, and it's showing greater than a negative. Now we can start homework. Sorry about that. You want to just write down? You just want to write down? Not for all the number?
Oh, like you don't even have to solve.
Yeah, you can stop.
You just don't have to graph it.
Yeah, you can. If you graph it, it just shows arrows everywhere. The interval notation is negative infinity, infinity. The number lines, just everything is highlighted. Okay, back at it. Back at it, people. 1 and 3. Any questions about 1 and 3? I already have this one up here. Can't believe I missed that on 3 with that. And I got a 4 instead of 8. 2 flips. How many slips will there be today? Someone should make a scatter plot of the number of slips and see which day it's tomorrow. Monday? Wednesday? Friday? You get here? Sorry, I'm WC's data. Maybe it's constant. Constant seven. Are you guys get it? Mark? Yeah, these ones are more confusing. What is happening? So 5 and 7 are these special ones. So if you checked your answers, and I truly hope you did, this one shows greater than a negative, always true. This one shows less than a negative, and that's never true. That's impossible. Does it have a number in front of it? Does it show my word? No, just like that. Okay. So absolute value is always positive. This is a contradiction. I'm actually very annoyed that it's even typed. Like, how could you? There's nothing more false than this statement right here. This is positive and can't be less than negative. So in college algebra, they call this a contradiction. They use like an English term. This contradicts itself. False, false, false. Here we say no solution. You could say never true. You could just say false. Because look, let's put a number in here, for instance, of 1. 5 plus 2 is 7. Is 7 less than negative 4? No. Let's try a negative 1. Negative 1 would be negative 5 plus 2 is negative 3. You want to try negative 2? So that would be negative 10 plus 2 is negative 8.
Oh, and then it's absolute value.
It is 8. The bars are going to take any negative and make it positive. Good job, Ken. Putting it out there. And that's going to happen with anything. It's always going to be false. So it's just annoying how they even type problems that are false like that. Just like, get it out of here. Wrong, wrong, wrong. A lot of people, for number 9, they got the positive answer right, but they did not get this one. And the mistake is you're not adding 8 to start. So you should have an 11 on your 2 problems. If you have a 3 when you started your if you put a negative 3 in, you messed up the process. First you add 8. Then you flip the sign and make it negative. So you should be working with the number 11 there. So right around 9, 11, 13 is when you should have questions. And hey, I couldn't get the right answer. I don't know what I was doing wrong. And I can tell you. Does anybody want to ask about number 9? Oh, because you mentioned, no, add it before the next one. Add it before you do the second. 11, same thing. Lots of students got stuck. You have to divide 3. Step 1, not make opposites. So you should be working with a 6 and a negative 6, not an 18 and a negative 18. 6 is where the problem starts. Especially with the odds. You're looking at number 12 right now. So you have a negative 3 right here. I think this is actually. This answer is. You can't spell that. Yeah, because I'm going to add both comes back over and it makes it positive. So you can't make a decision until the bars are isolated. Is that correct? And then you divide it, and then you decide can it be solved. That's such an important question. So many people don't know yet. You know what? Yeah, I bet you. Yeah. There's 13 and there's a tiny little 15. Oh, 15 is an exception. I wouldn't put 15 on a test or a quiz, but we can talk about it for a minute. Next, an extension. Okay, so you don't have full credit yet, but when you have it down, you show me. Questions on 13? The one question was, how come this has a negative? How come we can keep going? Why isn't this special? Why isn't this one special? You can't decide if it's special, if it's no solution or all real numbers, until you get the bars alone. Once the bars are alone, this is now a positive number. So it's not in that special category. So first you add 12.5, divide by 2. This is the absolute value problem. This work is just setting up. This is set up now to think about. This stuff all has to be done before I even think about what's happening there. Now I have a positive 4, everything's good to go. Green light. The silly thing about 15 is the 0. Zeros are so annoying. So I get a 0, I divide by 6, you can divide. You can't have a 0 in a denominator, but it can be in a numerator. And I get the absolute value is greater than 0. That's true. Okay, distance is greater than 0. Unless it's perfectly equal to, you can be 0 units from something, you can be right on it. Or you're definitely further than 0. So all distances, this is really true for all real numbers. Everything absolute value is greater than 0 because it's positive. The only issue is that there's no equal to sign. So we had to exclude anything that exactly equals 0. So when I solve this, really I'm thinking about what would make it perfectly equal 0, and it turns out a 12 does. If you put a 12 in here, it perfectly equals 0. So on my number line, I'm going to say that it could be anything besides 12. I'm going to put an open circle at 12. 12 is excluded from this problem because it makes it equal 0. Every other number is good to go. Tricky concept. Yeah. So we're talking about distance, right? And this is saying distance is more than 0, and positive numbers are more than 0. So I'm tempted to say it's all real numbers. And if there was an equal to bar here, I would say it's all real numbers. But this is actually claiming that it can't perfectly equal 0. So a 12 would make it perfectly equal 0. So I have to exclude 12. It's everything but 12. So it goes from infinity to 12, breaks at 12, starts up again at 12. Well, it would be positive 0 and negative 0. You don't start at the beginning. You don't go positive and negative until everything is removed. This is the step you go positive and negative. Right there. Yeah. Not as it's presented. First, you got to set the problem up. You got to move these things, and then you switch it. I like it. Didn't I talk about this in fourth period yesterday? No. Might not have been till sixth period. So a number in algebra, whenever we read a number, we put an X there or we put an N there. A number less than 6. That's algebra 1. A number less than 6. Reading that and writing this, algebra 1. Good to go. X less than 6. Then it says units from 0. Well, that's talking about distance. Units from 0 implies absolute value. So as soon as they put these extra words in their sentence, we have to put the bars in. So it's not just X is less than 6, because we could be over here on the positive part. These numbers are less than 6, but these are as well. These are less than 6 units from 0, so we use the absolute value bars. Questions on that one? All right, let's move on then. We're skipping 1.5 and we're going to 1.6. So we're gonna go to page like 77 or something. Just like fast forwarding to the future. And let's go to page 77. It is insane. Alright. Well, yeah. If you must. I never would have. Okay. Piecewise functions. This is a graph that's broken into pieces. And actually, I love these because there's most real life things don't stay consistent forever. They change and they shift, and there's movement in them. So we're gonna look at this, but we're gonna do it kind of quick. I'm not gonna have you talk to a partner. Again, page 77. This is talking about a digital wallet. They didn't put any names on here, but what's a digital wallet, you guys? What's a digital wallet? My credit card's in my digital wallet, but what's the app called that it's in? You got Apple Pay. What else? Cash App. What else? Google Pay. I got Venmo. I got Zelle. I got all that. I got PayPal. That's what we're talking about. This is a digital wallet. All right. So your friend on Monday has $300. That's Monday. They received a payment on Wednesday. They babysat on Wednesday for $50. They're up to $350 Wednesday. So I guess this is Tuesday. Then they paid their phone bill. They paid $150 on Thursday. So they dropped to 200. And then they got another $100 on Saturday and ended up Saturday and Sunday with $300. Okay. Now, if you read through all these questions, they say that this is presented badly. This is no good. There's errors here. What's wrong with the way they're presenting this digital wallet? It's not the best way to do this. Leo. What's wrong with this? That doesn't make any sense. The way they're showing this digital wallet. They got it cute graph here, but there's something really faulty about it in the way it's made. What's that? Well, she starts with 300. She pays 50, so she goes to 250. Or no, she earns 50, and then so the bank account, it is going up and down. What's wrong with it? What do you have?
There's two spaces between some of them, and then there's one space between that.
That is a good point. That's not it, but that's related. You're close. That's because nothing happened on Tuesday. So this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. He's close. Something wrong with that. What's wrong with it? What is going on here? It's represented falsely. The actual points aren't wrong. It's the way they go from point to point that is misrepresenting the situation. For instance, yeah? Yes, you got it. It looks like a gradual increase. It looks like, for instance, on Tuesday, your friend had $325. And then here, it looks like from Wednesday to Thursday that maybe their bank account decreased $2 each hour slowly. Like in the middle of the day, they didn't just have one or the other. And then from Thursday to Saturday, it looks like here on Friday they had 250. That didn't happen. They had 200, and then it jumps by 100 on Saturday and Sunday. So this is a bad representation. It's called a piecewise graph because it's broken into pieces, but there's a better way to show that, a more accurate way. Good job. Okay, how is this more accurate? Well, more accurately, I would say that this person was stuck at 300 until they got that $50. And then instantly it went from 300 to 350. It wasn't a gradual. And then they stayed here at 350 until they made that payment. And then right when that payment went, it jumped from 350 to 200. And then it stayed at 200 until they earned $100 more. And then it jumped here. Okay? So this with jumps and breaks, it's called discontinuous. It's not gradual. Is a better representation, for instance, of how a bank account goes up and down. There's a lot of other things that apply to this as well. This is what our graphs are going to look similar to this with open holes and closed dots and different pieces. It's called a piecewise graph. Okay, so let's move on from that application to page 78, and let's just look at what an algebra problem would look like. So, algebraically, we don't have anything to make sense of this, but we have one function broken into two pieces, okay? The if statement is really important. This says if x is less than 0, this is what the line will look like. So I'm going to look at the left side of the graph, and it should look like this, slope of 1 starting at -2. Now, this if statement tells me what part of the graph I'm looking at. If x is more than 0, the right side of the graph, the slope is 2 and the intercept is 1. Okay? So the function's broken up into parts, and how you know which part you're looking at is by the if statement. This has a left side and a right side, but it's all considered the same function. For instance, it's all considered the same bank account, but it's fluctuating differently. So it's all the same graph with different pieces. So on that same page, we're going to do number 1 right now. And you have 2 of these today. I've only assigned you 2 problems. And you're evaluating piecewise functions. So it's a little bit of a trick. So this is the example I'm going to do with you. For evaluate, maybe you want to write plug in. That's what evaluate means, for plugging in. We're going to plug in. But remember to only plug into one part. Okay, when I have an x value, I never plug it into 2 parts. I'm going to plug into only one part. Now, even though this is only one question, it's really five different x values I have to plug in. I'm going to plug in -8. I'm going to plug in -2. I'm going to plug in 0, 3.5, and 5. So I have to do 5 different calculations. For -8, I have to figure out which part. I'm only going to plug into one part. I have to figure out which part should I do. Should I do the top part? Should I do the bottom part? Well, -8 is less than 0, so -8 has to go to the top part. So I'm going to do x equals -8 into that top part. -2 is also less than 0, so I'm going to do x equals -2 into the top part. 0 perfectly equals 0, so I'm going to do x equals 0 into the bottom part. I'll do 7/2 in the bottom part because that x value is greater than 0. And I'll do 5 into the bottom part. So 2 end up being in the top, and 3 x values end up being in the bottom. I know it looks crazy for a while, but... All right, let me do the work. So first I'll do x equals -8. And I'm putting it in there. So -3 times -8 is 24. So h of -8 is 24. That's my first answer. I'm going to get answers. And then I'll do x equals -2. -3 times -2 is 6. So h of -2 is 6. That's my other answer. And now I will do 0. 0. I'm flipping it up. I'm not doing this one anymore. I'm plugging into the bottom one. I never do both. I have to decide top or bottom. This time is bottom. Sometimes there's 3 parts to pick from. So that's 0 plus 7 is 7. So h of 0 equals 7. And then I'll do 7 over 2. I'm going to use a calculator. I hate fractions. Just kidding. I love them. I got 14. H of 7 over 2 is 14. And last, 5, 2 times 5 plus 7 is 10 plus 7 is 17. H of 5 is 17. And I evaluated it. I evaluated it 5 times, and I used the correct parameters according to the if statement. Sorry, I don't know how that's out there. Use the examples and try to figure this out. I know it looks like maybe a foreign language right now. Does anybody have a good question for the group? You're working in page 83, number 1 and 2, so if you want to check it out. Someone last year asked, like, I thought you said we're plugging into one part, how come you did that? You know? That's a good question. Liam, you got a good question? You got a good question? Okay. What's going on? Let's put it up. There it is. Alright, so even though I've only assigned you number 1 and 2, 1, 2, 3, 4, 5, you have to plug in 5 times, so it's really like 10 plugins. Total. 2 looks tricky. Jeez. And number 2, it means it's a constant. It belongs in the function family constant. It's a y equals 3. So there is nowhere to plug in for that, so just keep it 3. Are there any x values between -1 and 2? That one and that one. So for this function, I'm going to say g of -1 equals 3 and g of 1/2 equals 3. You don't plug anything in, it's just 3. That's the hardest part. Don't look at that right now. Start with number 1. Try to figure out number 1 before you. I'm available after school today. If you have any concerns about like your assignment grade, maybe you don't have a 100 in there, you wish you did. Come see me after school and I can say, well, hey, I didn't see you finish this. Finish it right now for full credit. Or maybe you just need help because you can't figure this out. Come after school for 30 minutes. And then when you leave for the day, you have it done and you get it. It's so much better feeling like you understand than feeling like you're confused. So don't get caught up in the whirlwind of confusion.